Okay, hello, hi, this is Rani Ahmed with you, and this is lesson 18 on how to program using Haskell programming language. Now, in this lesson, I'm going to talk more about functions, okay, and we're going to emphasize on some things, revise some things, okay, that we took in earlier lessons, but it's important to highlight them and shed some light on them, okay? So, first of all, we're going to start with let and n, okay, versus any function and its where clause, okay. Now remember, that we usually use a definition for a function, and this is its definition. For example, f of x is x plus 3, and then you move to another function which depends on the first function f, okay, and you will have to define it, and there will be a clutter in the code, so you don't want to have and see this. So what you do, and sometimes it's preferred that you do it, is that I define z to take z as an integer that gives an integer, okay? And z of x is, see, I start with let f, okay? But z is actually f plus 2, okay? So this is where I postpone the definition of z, okay, in favor of f, because I want to highlight f more than I highlight z, okay? F is important to the reader, okay? It's like when you say things in English, like you put the verb before the subject while you really mean the subject before the verb, okay? And vice versa, okay? So it's a matter of where you emphasize your talk, your information. So this is the let before like I'm defining z as starting with f. Okay. Now I want to do it in the other way around, where I should define z, okay, using f, then I define f, okay? So I use the where clause, so it will be like something like this. This is not acceptable in Haskell to put it here. I mean, this is just a comment, okay? But as a definition, if it's working, it does not work. You have to put it outside of main. So z of x equals f plus 2, where f equals x plus 3. So I talk about f, but I don't know f. I can know f if I use the where clause, okay? So this is where f stands, okay? Now another thing in Haskell is I can define a variable, okay, inside the then statement part, C, of the if statement. So it will be like in C when you define a variable that just for clarity, you don't want to put it right on with its like the contents of that variable, like something like this. Let's see. I'll write something here as if you're writing in C. Okay, you say if x, or let's say use this matter. Anyways, just understand it. You're saying that if x is greater than 0, okay, then, or not then, you say like this, you close it like this, and you say directly that y is, okay, or LSQ as in the example, okay, equals log of x times log of x, okay, and then you say return sine sine of x multiplied by LSQ, okay? So this code is almost equivalent, and all it needs is just an else statement to say return 0, okay? So So this code is very much the same that you see in C. So what I'm saying here is that I'm defining a variable here just to be used in this equation, okay? And it will be directly here is tangent, okay? Tangent of LSQ. So it's just simple, very quick, okay? So just a matter of putting the definition of the tangent of LSQ here, okay? It's like a local variable thing, okay? Now, next thing, I don't want to take so much time with this, it's very clear. Now, second thing is I have something called lambda functions. Now, what are lambda functions? You know, lambda is as the word lambda is just by itself the letter in Greek language, okay? It's the L in Greek language. So it's like something very much like this, and this dash is inclined to the bottom, okay? So this line is just the nearest representation of lambda using ASCII characters, and the normal characters, the keyboard characters. And it's just a matter that you're defining an anonymous function. So lambda function is an anonymous function. So in the usual way, you always say t of x, f of x, z of x, all those are named, okay? You use like what you use here, fold R, map, all are well-known, readable, understandable functions from their names, okay? But those are anonymous. You don't know their names, okay? They are unknown. So you're just right on the spot, you're defining a function, okay? That will be used with folder right, and this is just the accumulation for the folder right, and we're folding this list to 1 plus 2 plus 3, okay? It'll be 6. Next, I have something called sections, and sections are just a section of the definition of the whole function, okay? So, for example, if I want to multiply a list, you use this as a function for multiplication in the map, okay? And map must have some here, somewhere here, okay? Some list here, okay? So I don't have to write it, okay? I can just define a function that is map of x star, and then later when you want to use multiply list, you're using it as if it's map in this way. See, I have let multiply of x, this is in prelude, equals map of x times. This means that I'm multiplying every element in the list using map, okay, with x, okay? So in the usage, you see multiply list to 1, 2, 3, okay? This is instead of putting those parentheses and the star, okay? It's easier this way. Now, last thing is flipping a prefix operator, okay, or a function into an infix operator, okay? So, this is the infix way, which means that I put the plus or the minus or whatever operator in the middle between two numbers, okay? And the prefix way, this is from Lisp to Lisp programming language uses this method. Plus is set as a prefix to the numbers, okay, at the start of this line. So you're saying 1 plus 3 plus, okay? So it will be 4, okay? So for example, I have the function lm 1, 2, 3, 4, 1, 2, 3, 4, okay? This is a list, and this is a number. lm is like a question. It asks whether 1 belongs to the list 1, 2, 3, 4. If it's okay, it will give me true, and it is true, okay? It's not I'm acting silly, but just think programmatically like a computer, okay? Of course, a computer is a dumb thing, but just we have to understand how the computer works. So, and analyze the way it analyzes. So to finalize, we can say that instead of using the 1 plus 3 method with the lm, okay, from the word element, yeah, we can use the the method of plus 1 2 3 1 3. We can use this method of the infix. So we use 1 and the backticks here, and we put the name of the function in the middle. Okay, so this is it. See, this is lm1 2 3 4, I get true, and lm5 is here and gives me 4 false. And this is when I put the lm in the middle as an infix operator, okay, and it gives me true. And this is good when I do some calculation like n line, okay, with the code, similar to what I've done here with the let. Okay, so that's all. Thanks for watching. Please subscribe to my channel just to get the updates. Click the likes, put your comments, whatever you want, and don't forget the ads. Okay, thanks for watching.